Go ahead. Hello everyone. Good afternoon to all guys. How are you all? Hello everyone. Good afternoon to all guys. I hope my voice is clearly audible to you all, and also my screen is visible clearly or not. Hello everyone. Good afternoon to all guys. I hope my voice is clearly audible to you all, and also my screen is clearly or not. Okay. If anybody having any problem regarding the technical things, you can respond in the chat box, or you can write your issues in the chat box. Okay. So we are continuing the chapter limit, continuity, and differentiability. Okay. So in the previous class also, we have solved 2 questions from continuity and differentiability, and also we have solved 7 to 8 questions from limit, right? In today's class also, we'll be solving some questions from limit and also some questions from continuity and differentiability. Those questions came into previous year examinations. Okay. So let's start solving the first question. So first question is, just a minute. Okay. So come to the first question. This is the questions came in 2020 JEE advance limit question. Okay. 2020 question है advance की. Okay. You can solve it now with me also. It is asking you need to find or evaluate the limit when extending to pi by 2, and in the denominator, in numerator, you are having 4 root 2 sine 3x up plus sine x, and in the denominator you are having some sine of a plus b, like this type of formula you have to apply. So this is actually limit of trigonometric functions. Okay, you have to use the trigonometric formula, identities, everything, and you have to solve it. Okay. So this is very good questions. Actually, it's a questions above mains level and below advanced level, but it's a previous year advanced questions came in 2020. So let's solve this question. So what is how we can solve it, these questions? Okay. So how can you solve it? The first thing is, in the numerator, you are having 4 root 2 sine 3x upon sine x. Okay. So let's solve. Limit extending to pi by 2. Same problem is happening. Sorry, guys. Let's just a minute. Okay. So limit extending to pi by 2, and in the numerator, you are having 4 root 2 sine 3x plus sine x. Okay. All of you know what is the formula for what is the trigonometric transformation formula? All of you know or not? Yes. So what is the formula for sine c plus sine d? That is 2 into sine of c plus d upon 2 into cos of c plus d upon 2. Yes. Is it or not? Is it? Huh? Yes or no? Yeah. So let's solve it. Let's solve it. 4 root 2 sine c plus sine d. Okay. So this will be 2 into sine of c plus d, that is 3x plus x is 4x by 2. So sine of 4x by 2 is 2x. Okay. So 2x into cos of c minus d. So 3x minus x is 2x by 2. That is x, cos of x. Okay. So numerator becomes this. And again in the denominator, we are having 2 sine 2x, 2 sine 2x, अच्छा 2 sin 2x, और यहाँ पे मेरे पास क्या है sin 3x, वैसे ही रहना 3 sin 3x by 2 प्लस cos of 5x by 2 minus root 2, if we'll take root 2 as common, okay, if we'll take root 2 as common, so then it will be root 2 into 1 plus cos 2x plus cos of 3x by 2, right? Okay, so this is my denominator. Now again simplify it, limit extending to pi by 2, and see, if we'll write this 1 plus cos 2x, so what will happen with 1 plus cos 2x? 1 plus cos x is 2 sin square x, 2 sin square x by 2, yes or no? 1 plus cos 2x, cos 2x is 1 minus 2 sin 2 sin square x, okay? So sin square, 2 sin square x by 2 will be 1 plus cos 2x. So cos x, 1 plus cos x is 2 sin square x by 2, right? But 1 plus cos 2x will be 2 sin square x हो जाएगा, है ना? So let's, and what I'm doing, let's simplify it. 4 root 2 into 2 sin 2x into cos x divided by 2 sin 2x into cos sine of 3x by 2 plus cos of 5x by 2, okay, minus, so this will be 1 plus cos 2x, 1 plus cos 2x will be अभी अभी बोला था ना तुम लोगों को, that will be root 2 into 2 sin square x in plus cos of 3x by 2. Is it or not? Yes. Sin 2x, okay. All of you, अच्छा, यहाँ पे भी मेरे पास और भी फॉर्मूला हम लगा सकते हैं यहाँ पे. What is the formula we should apply here? Guys, can you please solve it with me? Okay, you can solve it also by like this way. Now again simplify. If we take these two terms and use the formula of sin cos c plus cos d, so what will happen? You can check it now. 1 plus cos 2x. Cos 2x is 1 minus 2. Think about it. 1 plus cos 2x. What it will be? So cos 2x की formula क्या होता है? Let's see. Cos 2x is cos square x minus sin square x. Okay. So if we'll take it into sine of, okay, if we'll take it into or if we'll change it into sine in the terms of sine, this will be 1 minus 2 sin square x. Okay, so 1 minus cos 2x gives you 2 sin square x, right? But we need 1 plus 2x na. Also we can write this as 2 cos square x minus 1. Okay, so 1 plus cos 2x gives you 2 cos square x, right? 2 cos square x. Somrai, actually we are continuing the topic limit, continuity and differentiability. We are continuing the limit chapter limit, continuity, differential, and we are discussing the previous year questions of JEE Advanced basically. Okay, so 1 plus cos 2x becomes 2 cos square x, right? So this will be, sorry, actually this is the formula, 2 cos square x. This is 2 cos square x, right? And here for these two terms you must use the formula for sin c, cos c plus cos d. So limit extending to pi by 2, 8 root 2 sin 2x into cos x whole divided by, here it will be 2 sin x, 2 sin 2x into sine of 3x by 2 minus 2 root 2 cos square x. Okay, minus 2 root 2 cos square x plus cos c plus cos d, that is cos c plus cos d wala formula, that is 2 into sine of, that is what is that, minus or plus cos c plus cos d wala formula, 2 into cos of c plus d, is it or not, cos of c plus d. Okay, let's cos c plus cos d wala formula if we'll use, that will be 5x plus 3x will be 8x by 2, 8x by 2, that is, yes, 2 into sine of 4x, or we can take sine x into sine x by 2 into sine of that is 5x plus 3x by 2, 8x, 4x, is it or not, sine of 4x, 2 into sine of x by 2, 5x plus 3x, 8x upon, oh, that is 5x plus 3x by 4 na, it's already 2x, it will be 2x, right? Chalo, theek hai. Till here we have solved this. Let's again simplify it. Let's see, any term is cancelled out from numerator and denominator also. So here we are having sine 2x here, and the denominator we are having sine 2x here also we are having, and here sine 2x, but in this term we are not having any sine 2x, that's why we cannot cancel it also. Let's further simplify it. If you'll, what we can do, if you'll open this sine 2x, if you'll use the formula of double angle, and we'll write 8 to root 2 into 2 sine x into cos x, that is cos square x, divided by 2 sine x into cos x, that is 4 sine x into cos x into sine of 3x by 2 minus 2 root 2 cos square x plus 2 into sine of x by 2 into 2 sine x into cos x. Now we can observe here, we can cancel from the numerator and also from the denominator cos x, right? See, if we'll cancel this cos with this cos and this cos and this cos. Okay, so what we are having till now, right? So let's see. Now limit extending to pi by 2, and in the numerator we are having 16 root 2 or 16 root 2 sine x into cos x whole divided by 4 sine of x into sine of 3x by 2 minus 2 root 2 cos x plus 2 sine of x by 2 into that is 2 sine, sorry, 4 sine of x by 2 into sine of x, is it or not? Now when x tending to pi by 2, then cos of pi by 2 will be 0. That means this term will be 0. When we will put limit, this term will be 0, and numerator becomes 0 also, na? So no, we'll not apply this rule now. Till now we are having 4 into sine x, that is sine 3x by 2. Acha, here sine x. Acha, so if we'll further simplify it, you can observe here, again I am writing these things, limit extending to pi by 2, and in the numerator what you are having, just write that 16 root 2 sine of x into cos x whole divided by. So from these two terms, sine x is coming out as common. Yes, we can take sine x as common, 4 sine x as common. Okay, I am taking 4 sine x as common. So if I'll take 4 sine x as common, then it will be sine of 3x by 2 plus sine of x by 2 minus 2 root 2 cos of x. Now from the numerator and the denominator, can you cancel? Okay, no, till now we cannot cancel anything. Okay, let's apply the formula again. So limit extending to pi by 2, 16 root 2 sine of x into cos x. Actually, it's a question from trigonometry, you can say. So this will be 4 sine of x. If you use the formula of sine c plus sine d wala formula, if you use that, so this will give you 2 into sine of 3x plus 3x by 2 plus x by 2. That is 4x by 2. That is 2x by 2. That is sine x, 2 sine x by 2 into cos of c minus. So 3x minus x by 2. 2x by 2, that is x, into cos of x, it is giving. Okay. This will be anything we did the mistake here, guys. This is cos of let's check with me again it. We are having the last term as, let's check it again. Oh, this is actually minus, na? Oh, this will open with minus, yeah. Minus, this is minus, this is also minus, and this is also minus, this is also minus. Okay, or then this will be also minus. Okay, now this becomes 2 into sine of x by 2 into cos x. Okay, minus 2 root 2 into cos x. Now from the numerator and also from denominator, we can cancel cos x, cos x, cos x. So after cancelling, what you are having till now? Limit extending to pi by 2. That is in the numerator, you are having 16 root 2 sine of x divided by 4 into sine of x into 2 sine of x by 2 minus 2 root 2. Okay, we know sine of, when we'll put the limit directly, if you'll put the limit directly, so sine of pi by 2 will be 1. So in the numerator, we are having 16 root 2 upon 4 into sine of pi by 2 is 1 into 2 into sine of pi by 4. That is sine of pi by 2 upon 2, that is pi by 4. So 1 by root 2 minus 2 root 2. Is it or not? Yes or no? Clear? Okay. So finally, the answer will be coming as 8. Okay, the answer will be coming as 8. 4 into sine of, okay, sine of pi by 2 upon 2, that is pi by 4. Yes. So sine of pi by 4 is 1 by root 2. Okay, clear. So the answer is 8. Clear? So this is the question came in 2020 and the answer is actually 8. Clear, everyone? Is there any doubt? Mostly you have to use all the trigonometric formulae an identity. You must have to remember all those identities and formula of trigonometry. Then you can solve this type of questions. Okay. If you have any question in these questions, you can ask. If you have any doubt also, you can ask. Clear? Shall I move to the next question? Somrai, Amrita.
No doubt, sir.
Okay. Let's move to the next question. The next question is, let alpha be a positive real number and f is given f is mapping from R to R, g is a function which is mapping from alpha infinity to R. Okay, the domain of g is alpha to infinity, which is mapping from R to R. Be the functions defined by f of x is equal to sine of pi x upon 12 and g of x is equal to 2 log of root x minus root alpha upon log of e to the power root x minus. Okay, so you need to find the limit when extending to alpha minus or plus. It is alpha minus, or let me check. It is alpha plus. It is alpha plus when limit extending to alpha plus f of g of x. That means first you must have to find f of gx. So what is actually f of gx actually? Okay, chalo, ठीक है. Let's see. So before finding the limit, you must have to find this one, na? So let's find this one. Okay. You know, when g of x, g of x is f and g of x both are continuous function. Yes or no? Both are continuous function because f is sine of something, sine function is continuous always, and also g of x is also continuous because you have ln x, ln x. Okay, logarithm function is also continuous. So if both the functions are continuous, so you know always by using the properties of limit also we can write limit extending to alpha plus. So always limit goes, in case of continuous function, limit goes to inside of the function, right? So that means we can write here f of limit extending to alpha plus g of x. This you can write or not. So before finding these things, you must have to find the limit of g of x when extending to alpha plus. That is, if you'll find this on, so what is f of x given? That is sine of pi by 12. In place of x, you need to write this. What is that? Limit extending to alpha plus g of x. Yes or no? This is your function you need to find. So what is the value you will get after finding the value of limit g of x when extending to alpha? And you have to just put here and you will get the answer. So let's find the limit extending to alpha plus g of x, and g of x is given as 2 ln of root x minus root alpha divided by ln of e to the power root x minus e to the power root alpha. Okay, so this is the limit you need to find. So what we'll do, why I'm taking ln? Because here the base is given as e, right? That's why I'm taking ln. So how we can simplify it? So if we'll put alpha here in place of x, if we'll put the limit, so ln of root alpha minus root alpha, ln of 0, that gives you minus infinity. And also in the denominator you are getting minus infinity by infinity. So basically you are getting infinity by infinity form. But you can apply here a L'Hopital rule, but sometimes in my suggestion is in advanced examinations you should not apply always L'Hopital rule because it may be betray you, है ना? मतलब तुम लोगों को ये धोखा भी दे सकता है, ठीक? Sometimes fail भी हो सकता है. L'Hopital rule. Let's simplify first the given function. Okay, so limit extending to alpha plus what I am doing 2 into ln of root x minus root alpha. वैसे ही रहने दो उसको, न्यूमरेटर में कुछ हाथ मत लगाओ, ठीक है. So from the denominator if I'll take ln of e to the power alpha root alpha I am taking common. Okay, so then why I am taking root alpha as common, e to the power root alpha is common, because in the numerator, in the argument of logarithmic, you are having root x minus root alpha. So I am trying to make also in the denominator, in the argument of log, root x minus root alpha, because we can, maybe we can use some standard logarithmic formula. Okay, so after taking e to the power root alpha is as common, what you are having? So e to the power root x minus root alpha minus 1. Yes or no? These things you are having now. So can you use any formula here, guys? Can you use any formula here? Or till now, no. Nothing is simplified. Okay, so let's further simplify it. Limit extending to alpha plus 2 into ln of root x minus root alpha divided by, if you use the properties of logarithmic, ln x into ln of xy will be log of x plus log of y, that is ln of e raised to root alpha plus ln of e to the power root x minus root alpha minus 1. Yes. Okay, so again we can simplify it as limit extending to alpha plus numerator becomes 2 ln of root x minus root alpha divided by, this becomes ln of e to the power root alpha. This becomes root alpha plus ln of e to the power root x minus root alpha minus 1. Okay. Okay, so all of you know, guys, we can use a replacement here. We can use a replacement here. How? All of you know one formula. So when limit extending to 0, you are having limit extending to 0 e to the power x minus 1 upon x. This gives you 1. Okay, so if you use this replacement, that means we can say here, this is same as, we can replace e raised to x minus 1 as x. Is there any problem? No, right? We can use. Similarly here now you can see when extending to alpha plus, guys, when extending to alpha plus, so root x minus root alpha, when extending to alpha plus, you can see alpha, that implies root x minus root alpha tending to 0 or not? Yes. So we can replace, in place of e raised to root x minus root alpha minus 1, we can use only root x minus root alpha. By using these substitutions, we can, or you can, by using this replacement, we can use that one. So this becomes limit extending to alpha plus 2 into ln of root x minus root alpha divided by root alpha plus e to the power, what you are having, ln of e to the power root x minus root alpha minus 1. So in place of e to the power x minus 1, here I am substituting x. So in place of root x minus e to the power root x minus root alpha minus 1, we can substitute here root x minus root alpha. No issues. You can see. You can replace here. Right, guys? Okay. So now see, if you use again, see here, if you use extending to alpha plus here also. So what you are getting actually? Also ln of 0 by ln of 0 minus infinity by infinity or infinity by infinity formula we are getting here. Okay. So guys, my suggestion is, when suppose we are taking a small example, suppose like if we'll ask you limit, find limit n tending to infinity 2n upon root alpha plus n. So quickly what you will do, you will just divide n with numerator and denominator, and you will get, you will tell me what is the answer will be. When you will divide n with numerator and with denominator, you will get answer as 2. So here also we can treat this ln of root x minus root alpha as n. Treat this ln of root x minus root alpha as n here. How? We are using n in this example. Similarly, we can take this ln of root x minus root alpha as n, because you know na, because alpha x tending to alpha plus, okay, so ln of root x minus root alpha tending to infinity, yes or no, minus infinity, yes or no. So in place of here we can write instead of ln of root x minus root alpha tending to minus infinity, you can write, no problem. So this will be 2 into ln of root x minus root alpha divided by root alpha plus ln of root x minus root alpha. So in place of n only I have substituted here root ln of root x minus root alpha. Here you can use this one. Okay, okay, any doubt, Som, Dai, you can ask. Okay, now
सर ये लास्ट वाला दोबारा रिपीट कर दोगे?
sorry, what is the question?
सर लास्ट क्वेश्चन, सर ये लास्ट पार्ट आपने एक बार रिपीट कर दो, ये जहाँ पे आपने ये लिमिट्स एंड टेंड्स टू 0 पे किया आपने ये वाला,
ये वाला, दिस वन,
हाँ ये पोर्शन।
ठीक है, देखो, सो देखो और एक बार मैं रिपीट कर देता हूं, ठीक है, इसको भूल जाओ, ठीक है। सपोज थिंक you are having one limit. I am asking you to find limit extending to infinity 2n upon root alpha plus n. So what you can do? What you will do? Limit extending to infinity. Sorry, this is n. N tending to infinity, that is 2n upon n. You can divide n with the numerator and also
yes
with
sir, n से divide करते हैं,
root alpha by n plus 1. So this becomes 2 or not? So limit becomes 2. Okay, but in the question, this is the example for your understanding I have used here. Okay, this is the example for your understanding I have used here. But in the question, in actually in our question, what you have to use? In place of n, we are having ln of, what I am saying, treat ln of root x minus root alpha as n. Okay, as n. Understood? Now it is clear?
okay sir,
Okay, so n के जगह में अगर मैं ln of root x minus root alpha ले लूं, ठीक है, so the answer, ये लिमिट के आंसर क्या आ जाएगा? 2 आ जाएगा ना, because both the expressions are similar. If n, we are treating n as ln of root x minus root alpha. Okay, so here also na, this is my n, see, this is my n and this is also my n.
सर लेकिन ये आपने लिमिट कैसे सेटिस्फाई की? वहाँ पे लिमिट अल्फा प्लस को अप्रोच कर रही है, यहाँ लिमिट,
हाँ, ये था लिमिट एक्सटेंडिंग टू, लिसन टू मी, यहाँ पे था लिमिट एक्सटेंडिंग टू अल्फा प्लस, बट यहाँ पे था लिमिट एक्सटेंडिंग टू इंफिनिटी। यही चीज पूछ रहे हो तुम?
यस सर,
यस, सी, व्हेन एक्सटेंडिंग टू अल्फा प्लस, राइट, व्हेन एक्सटेंडिंग टू अल्फा प्लस, देन टेल मी ln of root x minus root alpha tending to ln of
इंफिनिटी जाएगा,
or
0
not?
जाएगा,
And ln of 0 is minus
not
infinity,
defined,
or infinity or minus infinity, you can say. So here we can use minus infinity. Okay, you can use here in place of, that's why I am writing here na,
okay sir,
ln of root x minus root alpha tending to infinity, numerator में क्या है, that is 2 into ln of root x minus root alpha divided by root alpha plus ln of root x minus root alpha. Now this will be giving you, what is the answer? 2 or not? Tell me. Now it is clear?
Yes, sir, clear.
Yes. So limit of gx when extending to alpha plus is 2. You are getting, what is the answer? You are getting 2, right? Okay. So the answer will be, what is the answer will be? Now tell me, what is the answer? Sine of pi by 12 into 2. Yes or no? So answer is 2, 6, sine of pi by 6. Okay. So last year this question was coming actually, na? Last year this question was came in your JEE Advance 2022 questions hai. So sine of pi by 6 is 1 by 2. So answer is 1 by 2. Clear everyone? Clear? Som?
Yes, sir, clear.
Amrita? Okay. So if it is clear, let's move to the next question again. Okay? Okay. So let's move to the next question. Here, yeah, very good, Amrita. Let f of x is equal to 1 minus x. This function is given into cos of something, okay? For x is not equal to 1. Then it is asking which option is or are correct, right? Which option is or is correct? That means here in the option you are having 1 plus 1 minus, right? That means you need to find the left hand limit and right hand limit of f of x. Okay. So limit. So let's find first left hand limit. So multiple correct answer type question. Okay. Chalo. Okay, now try with me also. So it is given that limit. Okay, so in when we are finding left hand limit, what should you do? क्या करना चाहिए मुझे? So x tending to 1, left hand limit, that is 1 minus h. Okay, so when x tending to 1 minus h. Okay, चलो तो h tending to 0 हो जाएगा ना. So limit h tending to 0, 1 in place of x you need to substitute 1 minus h. So 1 minus h, 1 plus mod of 1 minus of h, this divided by 1 minus of h into cos of 1 by 1 minus of h. See, this is my left hand limit. Okay, you can see here 1 will be cancelled out, and this one will be cancelled out, right? Okay, chalo, ठीक है, कोई नहीं. This one will be cancelled out also. Here 1 will be cancelled out. So what you are having? Let's see. Limit h tending to 0. Here you are having h, and 1 plus minus h, mod of minus h is h. So h into 1 plus h, right? H into 1 plus h you are having or not? This is actually given us. Oh, this no. Actually, we did the wrong thing. This can't be cancelled out, na? Because this is 1. This is multiplied with this, na? Sorry. चलो ठीक है, ये मिस्टेकली हो गया. Okay, so this will be 1 minus h into 1 plus h divided by h into cos of 1 by h, right? Okay, चलो ठीक है, कोई नहीं. So limit h tending to 0. So this will be 1 minus h into 1 plus h will be 1 minus h square. 1 square minus h square, that is 1 plus h square divided by h into cos of 1 by h. Yes or no? Clear? So finally what you are getting, limit h tending to 0. 1 will be cancelled out, and a square upon h is h into cos of 1 by h. Oh, cos of 1 by h, right? So when we'll put the limit, okay guys, when we'll put the limit, so h tending to 0, right? So when h tending to 0 and cos of something, so this will be giving you the value in between -1 to 1. yes or no? -1 to 1 के बीच में वैल्यू देने वाला है. So 0 into some finite value. 0 into some finite value will be 0, right? So left hand limit becomes 0, right? So left hand limit becomes 0. So limit extending to 1 minus f of x is 0. Is that clear to everyone? This is the first option we have checked. Okay. Now find the right hand limit. RHL. That is limit x tending to 1 plus h, right? So h tending to 0. H tending to 0, and the function is given as 1 minus x into, that is 1 minus 1 plus h into, let me check. What is the function I have taken? Yes, 1 minus 1 plus h into, that is 1 plus mod of 1 minus 1 plus h. Okay. 1 plus h into this divided by 1 mod of 1 plus h into cos of 1 by 1 minus 1 plus h. Clear? ठीक है, कोई नहीं. So let's solve. Limit h tending to 0, this becomes 1 minus 1 plus h, and ये 1 तो cancel हो जाएगा. This is also 1 plus h divided by, ये 1 तो cancel हो गया, that is h into cos of minus h, that is cos of 1 by minus h. Cos, because cos is an even function, we can write this as cos of 1 by h. Right? Okay. चलो ठीक है, कोई नहीं. So limit h tending to 0, 1 minus 1 plus h whole square divided by h into cos of 1 by h. Okay. Now if we'll open the perfect square also, so limit h tending to 0, 1 minus 1 minus h square minus so this will be 1 minus 1 square minus h square minus 2h. Okay, 2h divided by h. So this will be cancelled out into cos of 1 by h. So limit h tending to 0. If we'll take minus h as common also, so this will be h plus 2h, h plus 2 divided by h and cos of 1 by h. So from here h will be cancelled out, and what you are having, limit h tending to 0 minus of in the denominator, okay, minus of h plus 2 whole into cos of 1 by h. Acha, we know this will be giving you in between the value -1 to 1. So that means this is one of the finite value. This will be giving you finite value. So finite into ये क्या हो जाएगा फिर? How we can find finite into h plus 2. So 0 plus 2 na. So -2 into what you are getting? If we'll put the limit, we are getting -2 into some values in between -1 to 1. That means we are getting some finite value, है ना? We are getting some finite value, but finite value we are getting. So it may be na this cos of 1 by s can be take any values in between -1 to 1, and in between -1 to 1 there are infinite number of real numbers. So when you will multiply by -2, so it will be giving you what? Some constant or anything. So let's check the option again. What is happening? Limit f of x 1 plus f of x does not exist. -2 into, if you'll put the limit na, so -2 into some values in between -1 to 1, है ना? So right hand limit will be any values. It can be any values na, है ना? But in case of left hand limit, we are multiplying with 0. Any constant in between, any real number you can choose from -1 to 1, and you will multiply with 0. That will be giving you 0. But in this case, here we are having -2. But if you choose in between these two, any point in this interval, then it will be giving you lot of infinite number of values. So this is not finite, not exist. So right hand limit does not exist. The answer will be right hand limit does not exist. Okay. This will be correct. Right hand limit does not exist, and left hand limit to exist karta is 0. That is 0. This is wrong, and this is wrong. So B and D are the correct options. Is that clear? Clear, beta? Som, Tarun, Amrita. Clear,
Yes,
everyone?
sir.
ठीक है. This is also a 2000, I think 22 का question है. You can check also. Right? Okay. So if you have any doubt, you can ask also. Okay. Let's move to the next question. Wow, very big question. Chalo, ठीक है. Here it is asking, g of x this, and x is lying between 0 to 2. Okay, and m and n are integers. ठीक है. M is not equal to 0, n is greater than 0, and let p be the left hand limit, left hand derivative of mod of x minus 1. Okay, at x is equal to 1. So that is left hand derivative of mod of x minus 1 at x is equal to 1 is p. So what is p? So at x is equal to 1, if we'll put, so if we'll find limit extending to 1 minus of this function, so this will be, this becomes, this changes to this will be changing to what? When extending to 1 minus left hand derivative, that is extending to 1 minus. Okay, so 1 minus means it will be, p will be, what will be p? So this function becomes, when extending to 1 minus, this function becomes 1 minus x. So this is equal to my, this is my function. This is my function we are getting, and it is given that p is the left hand derivative of this function at x is equal to 1. Okay, so if we'll take the derivative of this function, so p will be, if we'll take the derivative, of this function, 1 minus x, that will be giving you minus 1. So p is equal to minus 1 I am getting. So left hand derivative we are getting minus 1, right? समझ में आ रहा है कि नहीं? देखो, this is the left hand, p is the left hand derivative of the function mod of x minus 1 at x is equal to 1. So that means when you are finding x tending to 1 minus left hand derivative, when you are finding, That means you need to take 1. The point x is less than 1. So when x is less than 1, this mod will open with minus sign, negative sign. So this function becomes 1 minus x. So then again derivative it. When you differentiate this function, you will be getting minus 1. So p becomes minus 1. So left hand derivative of this mod of x minus 1 becomes minus 1. Okay, we got p is equal minus 1. This is most important thing. And also it is given that, okay, this p is limit extending to 1 plus of g of x is equal to p. That is minus 1. Okay, so p is minus 1. Right? So we got a very good information from the given information. Okay, so limit, so already g of x is given, right? G of x is given. So what is g of x? So limit extending to 1 plus g of x is given as x minus 1 to the power n divided by ln of cos की power m minus cos की power m x minus 1. It is given or not? Yes. One. Now you need to find the value of n and m, right? You need to find the value of n and m. Okay, चलो ठीक है, कोई नहीं. Can you use the L'Hopital rule here, guys? Can you use the L'Hopital rule here? If we'll put the limit 1 minus 1 will be giving you 0, and this will be cos of 0 is 1, ln of 1 is 0. Okay, so this is in the form of 0 by 0. So we can use here the L'Hopital rule. Okay, if we can use the L'Hopital rule, then use the L'Hopital rule, no problem. So limit extending to 1 plus, so this will be n into x minus 1 to the power n minus 1 divided by, this will be, again, if we'll use the properties of logarithmic, this index power will be multiplied here or not. So what directly I am writing here, instead of writing m here, I am writing, or I am multiplying m with the main expression, that is m into ln of cos of x minus 1, right? So m को वैसे ही रखो, because m is constant, and derivative of ln of this, so 1 upon cos of x minus 1 into derivative of cos of x minus 1 is minus of sin of x minus 1, and x minus 1 की derivative, that is 1. ठीक है? So finally you are getting, this is given as minus 1, don't forget. Okay, so finally we are getting limit extending to 1 plus n into x minus 1 to the power n minus 1 whole divided by m into sine of x minus 1. So it is given sine of minus of sine of x minus 1 divided by cos of x minus 1. Okay, so let's put the limit. What are you getting? It will put the limit extending to 1 plus okay, what are you getting? So this is also giving you by 0 formula. ठीक है, so क्या यूज कर सकते हैं? Okay, let's use the replacement again. As you know, limit extending to 0, sine of x divided by x gives you 1. All of you know this or not? ये तो पता है ना सबको? That means we can substitute sin x as well as x. है ना, sin x के जगह में in place of sin x we can use x. है ना, in the last questions you have used the replacement. है ना, so here the limit extending to 0 plus, here also extending to 1 plus, when we will put, when x tending to 1 plus, then x minus 1 will be tending to 0, right? So you can use na. So here, sorry, you can replace 1 by cos of x minus 1. So instead of sine of x minus 1, we can use, instead of sine of x minus 1, we can use x minus 1 only. Yes or no? You can use or not? Right? We can use or not? Yes, we can use. So in the right hand side, we are having minus 1. So this minus will be cancelled out. Let's take. So finally, what you are having, limit extending to 1 plus n into x minus 1 to the power n minus 1 divided by m into x minus 1 divided by cos of x minus 1, right? Which is equal to 1. ठीक है, कोई नहीं, चलो. Oh, now let's check. Option wise check करो ना. So in the given option, it is given that when n is equal to 1, m is equal to 1. If you'll put n is equal to 1, put n is equal to 1. Okay. अगर हम n is equal to 1 put करेंगे तो, so this will be giving you 1 into 0 to the power 1 minus 0 to the power 0 divided by m into this will be 0 upon, sorry, 1 minus 1, 0 upon cos of 0, that is 1. Okay. 0 m into 0, so this is 1. This is not giving you 1, है ना? So m मुझे 1 मिल रहा है क्या यहाँ से? When you are putting n is equal to 1, you are getting, is there any chances of getting m is equal to 1? No, because when we will cross multiply, we will be getting m into 1 is equal to 0 by 0. No, we are not getting m is equal to 1. So first option is wrong. It is not correct. So we cannot put n is equal to 1 because it is giving you a undefined or undefined form, undefined number you are getting. है ना? We are not getting any specific value for m or any particular value for m. Okay, just put in the third option, n is equal to put 2, n is equal to 2. If we put n is equal to 2, put n is equal to 2, अच्छा क्या है? अच्छा, in this case, if we put n is equal to 2, what will be happening? Let's see. This will be 2 into 2 minus 1 to the power, sorry, 1 minus 1 to the power 1. So 0 to the power 1 divided by m into, this will be 1 minus 1 by cos of 0, that is 1. Okay, and in right hand side we are having 1. ठीक है? Okay. So when you are putting n is equal to 2, we are getting, oh, x directly, चलो ठीक है, और एक एंगल से भी देख सकते हैं हम लोग. डायरेक्ट do one thing, if we'll take this x minus 1 to the numerator, what is happening? Extending to 1 plus n into x minus 1 to the power n minus 2, right? And divided by m, and cos of x minus 1, that is cos, when we will put limit, so cos of 0 will be 1. So n by m into, that is limit extending to 1 plus n by m x minus 1 to the power n minus 2 is equal to 1, right? Now, if we'll put n is equal to 2, अगर मैं n इज इक्वल टू 2 पुट करूं तो मुझे क्या मिलेगा 2/m एंड 2/m इंटू 0 to the power 2/m, we are getting 2 n upon m na. So n upon m is equal to 2/m into, that is 1 plus. So 1 plus means 0 to the power n minus 2. 1 plus means we can take 1 point something, 1.0000009. Suppose I am taking, and 1 minus 1.00009 minus 1 will be giving you 0.0000009 to the power 0, right? Here in the power you will be getting 0, that means 1. Something to the power 0 is 1, is equal to 1. So here I am getting, if m is equal to 2, at n is equal to 2, I am getting also m is equal to 2, right? When we are putting n is equal to 2, I am getting m is equal to 2. So option C is correct, right? Option C is correct. When we are putting n is equal to, we are getting m is equal to 2 also. You can check it also here. No, already we have checked it, right? Okay, now for the last option, what is given? n is greater than 2. n is greater than 2 के लिए, if we'll put n is greater than 2, okay, so this will be limit extending to 1 plus. Oh, no need to put limit here now. Okay, so directly put, we can check any number you can take, that is 3/m. Suppose I'm taking 3, n as 3. So this will be 1.00. You can take this way, 1.009 minus 1 to the power 1 is equal to 1. No. So m is equal to, you are getting something 0.0009 to the power 1 will be giving you 0 point something. So it will be giving you another number. So for n is greater than 2, we are not getting m is equal to 2. So option D is also wrong. Right? Option D is also wrong. So only option C is correct. Clear everyone? Only option C is correct. Clear? Clear not? Is there any doubt you can ask? कोई भी स्टेप में कुछ भी डाउट है तो पूछ सकते हैं, पूछो. If you have any doubt, you can ask. Guys? समझ में आया कि नहीं? सोम, अमृता, तरुण, YouTube guys also you can ask.
सर 0 की पावर 0 लेंगे तो सही माना जाएगा? 0 की पावर 0 को
not
बनने
taking 0 to the power 0 ना. When we are taking 0 to the power 0.
सर यहाँ मेरा तो था मैं x minus 1 में n minus 2. x minus 1 की पावर n minus 2 में मिला तो था मैं 0/0 की फॉर्म, 0 की पावर 0 की फॉर्म.
0 to the power 0 form. Yes. You can take 0 to the power 0 form, you can take, but in the question it is asking to find the value of n and m, right? So if you take 0 to the power 0 form, no. So how if you are getting 0 to the power 0 form? When you are putting the limit extending to 1 plus, right? So that means 0 to the power something you are getting, na? We don't know what is n, na? Is that or not? When you are putting n is equal to 2, right? When you are putting n is equal to 2, what you are getting? n/m into, sorry, n is 2. So 2/m, that is, say you can check here, 2/m, that is 1 point something. Okay. What you are getting? 1 point something.
Okay, sir. Okay, sir. Okay, sir.
You are getting or not?
Yes,
1
sir.
point
Got
something. So 0 point something you are getting in the base. This will be 0 point something, and in the power you are getting 0. So something in the power 0 is 1. So here we are getting 1. That's why we are getting m is equal to 2. Only in this case When n is equal to, we are getting n is equal to. Clear?
Yes, sir. Yes, sir.
ठीक है. Let's move. Next question. Now, let E denote the base of the natural number. Let's leave the value of real number A. Achha, we need to find the value of A. For which is the right hand limit of this function is equal to non-zero real number. Okay, it is given that limit extending to 0 plus 1 minus x to the power 1 by x minus e to the power minus 1 divided by x to the power a, which is equal to a non-zero finite number. Okay, which is equal to giving you a non-zero finite number you are given. Okay, so you need to find the value of a. For which value of a? Okay, so let's simplify it and try to find the answer. कैसे करेंगे? How we can solve it? Okay, I'm giving you some hints. Okay, always remember, when in the base and also in the power of some function you are having variable, right? Whenever you are getting in the questions in the power of some functions you are having variable, just use this formula, that is logarithmic. What is logarithmic? We know na, if a raised to b is equal to c, then log of c to the base a is equal to b. We know this, right? So use this one and try to write this function, this given question in this format. So we can write this as limit extending to 0 plus e to the power 1 by x into ln of 1 minus x minus e to the power minus 1 divided by x upon to the power a. Is there any problem? We can put or not. और लिख सकते हैं कि नहीं बोलो? समझ में आ रहा है कि
लिख
नहीं?
सकते हैं सर.
ठीक है, अगर हम ऐसे लिख सकते हैं, कैसे? अरे उसको y मान लो ना. अगर हम उसको y मान लेंगे और वो दोनों साइड में log लगा देंगे तो क्या हो जाएगा? 1 माइनस एक्स. तो क्या हो जाएगा? अरे 1 माइनस एक्स विल बी, सॉरी, जो पावर होगा 1 बाई एक्स विल बी मल्टीप्लाइड विथ ln ऑफ 1 माइनस एक्स. यस और नो? एंड y विल बी e टू द पावर दैट. ठीक है, ओके. नाउ हाउ वी कैन सॉल्व इट? अभी भी तो नहीं हो रहा है ना, बहुत कॉम्प्लिकेटेड लग रहा है फंक्शन. ठीक है, तो कैसे सॉल्व करें? माय सजेशन इज, इट्स अ हिंट फॉर यू, you can use the series expansion. Okay, all of you know what is the series expansion. Before going through the advanced
Yes, sir. Yes, sir.
all of you must know what is the series expansion of ln of 1 plus x, sin of x, okay, cos of x, all these things है ना, all these series expansions you must have known. ठीक है, so log of 1 plus x की expansion क्या होता है? कोई बता सकता है मुझे? That will be x minus x square by 2 plus x cube by 3 and so on. ठीक है, alternatingly. Okay, and all of you know now what is e raised to x? What is the expansion of e raised to x? Anyone of you answer this? That is very simple. 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on. ठीक है, so from this, by looking to this series only, you have to remember the expansion of log of 1 plus x and log of 1 minus x. If this is the expansion of log of 1 plus x, so what will be the expansion of log of 1 minus x? So instead of x, here we are writing minus x. That means it will be minus x square by 2 minus x cube by 3 and so on. So this is the expansion of log of 1 minus x, right? Now use this series expansion. So this will be okay. limit extending to 0 plus e to the power 1 by x into, in place of ln of 1 minus x, I'm just writing this minus x square by 2 minus x cube by 3 and so on, minus e to the power minus 1 divided by x to the power a. It is given. Yes or no? Right or wrong? We can write or not? Okay. Chalo. Let's multiply 1 by x with this bracket. Chalo. After multiplying, what you are getting? Limit extending to 0 plus, it will multiply e to the power 1 by x, it will multiply, then what you are getting? Minus 1, then we'll be getting x by 2, x square by 3 and so on. You are getting this minus e to the power minus 1 divided by x to the power a. Acha. Acha, can you tell me, in the numerator, we can take e to the power minus 1 as common. Okay. And we know e to the power minus 1 is constant. So I'm taking e to the power minus 1 to the outside, limit extending to 0 plus, after taking e to the power minus 1 as common. So what you are getting? E to the power minus x by 2 minus x square by 3 and so on, minus e to the power minus 1 by x to the power a. Okay. Sorry. Here we have taken already e to the power minus 1 as common. So here you are having 1. Yes or no? Okay. So this is the limit now we need to find. Okay? Clear? Acha. Now use the replacement. Replace. You know, already we have used these things once. You know, when limit extending to 0, that is e raised to x minus 1 by x gives you 1. Right? That means here, in place of e raised to x minus 1, we can put x. That means what you are having in the power of exponential, you need to substitute only, instead of e raised to x minus 1, we can substitute or we can replace x. Okay. So in the question here, if we'll use the replacement, this will be e to the power minus 1, limit extending to 0 plus, this will be, what you are having in the power of exponential, that is minus of x by 2 minus x square by 3 and so on, this divided by x to the power a. Right? This you are having. This is the thing you are. Put the limit now, and what is the options are given? Swelling. Oh, it's a numerical question. Okay, no issues. And it is given as, it's a non-zero finite real number. Nah? It's a non-zero finite real number. Okay, so it's to be real non-zero finite number. So the value of a must be, acha, put a is equal to 1. If we'll put a is equal to 1, so what you are getting? E to the power minus 1 into e to the power minus 1 into limit put kar lo na. So this will be 0 by 0 form na. If we'll put a is equal to 1, what you are getting? A is equal to 1. और let's again simplify this one. और भी एक बार हम simplify कर देंगे उसको. Limit extending to 0 plus. Okay. So if we'll divide, chalo. If we'll divide x in the numerator and also in the denominator. What you are getting? Here I am getting minus 1 by 2. This will be giving you x by 3.
-1/2 ही आ रहा है.
हाँ, -1/2 ही आ रहा है ना. Very good. So
Yes,
x to the power m-1 है ना. Okay, so you need to remember one thing. Okay, so when you are getting such type of limit, okay, in advanced question na, so just you have to substitute the in place of the value will be the first. What is the coefficient? You know, what is the coefficient of this x will be -1/2 है ना, will be your answer है ना. ठीक है. Okay, if you'll compare both x, so a will be limit to put a is equal to 1 now. अगर हम 1 पुट करेंगे तो a is equal to 1 पुट करेंगे तो this will be a to the power -1 into x. हाँ, अरे यार सही में कुछ जरूरत ही नहीं है कुछ करना भाई, खत्म. ये तो डायरेक्टली तुम आंसर भी ये लिख सकते हो. सच टाइप ऑफ लिमिट के लिए तुम्हारा जो x की कोफिशिएंट होगा ना -1/2 विल बी योर आंसर. और नहीं तो उसको नेक्स्ट स्टेप में अगर मैं जैसे किया था वैसे करोगे तो the first constants you are getting in the series, that will be your answer. And again you can see here also this will be when we are taking a is equal to 1, so x will be divided by -x/2 है ना. अरे ये क्या हो जाएगा, -x/2 -x² and so on divided by x. So when x will be divided by 2, so this will be -1/2. And when you are dividing x with x²/3, you are getting x/3 and put the limit, so 0/3, 0. So you are getting 0. So simply you are getting e to the power -1 into -1/2, right? E to the power -1 into -1/2. Okay, so this will be a non-zero real finite number you are getting. Okay, non-zero real finite you are getting in case of when a is equal to 1. So the answer will be 1. A for the values of a, for real values of a is equal to 1, we are getting this limit is non-zero real number. Is that clear? Non-zero real numbers. Okay, you can check also. You can see, sir. You can ask also, sir, you have checked for a is equal to 1. Sir, if you put a is equal to 2, you can check now. When you are putting a is equal to, what is happening? So that will be limit will be e to the power -1 into x² divide होगा ना. In this case, -x/2 -x²/3 and so on divided by x². So when you are dividing x², so you are getting something upon x. Okay, so something upon x means 1/0 you are getting, that is infinity. Okay, infinity minus something plus infinity something 0, ऐसे कुछ मिल रहा है. So इस टाइप का क्वेश्चन में ना इंफिनिटी के तरफ जा रहा है मुझे लग रहा है. ठीक है ना, यू कैन चेक, ट्राई इट है ना. देखो ना, if you divide this x², it will be giving you -1/2x and 1/3. सिमिलरली यहां से भी ये जो जब भी हम लिमिट एक्सटेंडिंग टू 0 प्लस पुट कर देंगे तो ये तो इंफिनिटी की तरफ जा रहा है ना. सो इंफिनिटी प्लस और माइनस समथिंग विल बी गिविंग यू अगेन इंफिनिटी है ना. सो व्हेन यू आर पुटिंग a is equal to, we are not getting any finite, any non-zero real number. We are getting no non-zero real numbers we are getting when you are putting a is equal to. But here the only case is when you are putting a is equal to 1. There is only one case when you are putting a is equal to 1, we are getting non-zero real number. Because you can see here when you are dividing x, with the numerator we are getting minus 1 by 2 plus 0 something. Okay, so right, limit extending to 0 plus e to the power minus 1. Okay, so this is actually e to the power minus 1 into minus 1 by 2. So e to the power minus 1 into minus 1 by 2 is giving you non-zero real numbers. Is that clear to everyone, guys? Tell me, clear or not? Tom, Tarun, Amrita, clear? Yes or no?
Clear, sir.
Clear, no doubt? No doubt, na? ठीक है, ठीक है. Okay, let's move to the next question. Oh, it's a lengthy question actually, but I can give you one hint. Okay, so let's solve. It is given in the question. F is a function. This G is this defined by this G this ये हो गया. And greater essential function f of g of x, f of g of x is mapping from this composite function f of g of x. Okay, suppose c is the number of points in the interval minus 1 to 1 at which f of g of x is not continuous, and suppose d is the number of points in the interval minus 1 to 1 of which at which f of g of x is not differentiable. Okay, then अच्छा 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 अच्छा, तो ये दिया है क्वेश्चन में, ये दिया है कि c is the number of points in the interval minus 1 to 1 when f of g of x is not continuous, and d is the number of points in the interval minus 1 to 1 when the f of g of x is not differentiable. So basically you need to find c and d, then will be you are asking to find c plus d. What is the value of c plus d? Right? C, what is c? C is the number of discontinuity in the interval minus 1 to 1 of the function f of g of x, and d is your number of number of points of non-differentiability in the interval minus 1 to 1. Okay, and it is already given that f of x and also g of x is already given, right? Chalo, let's f of x is given as mod of 2x minus 1 plus 2x plus 1, right? And g of x is given as x minus greatest integer function of x, which is fractional part of x. It's very simple, na? It is fractional part of x, it is given. Clear? Okay. So we need to observe the given function f of x and the interval, in the interval minus 1 to 1, right? So if we'll break this, intervals according to the given modulus function. So what are the critical points? 1 by 2 will be your critical points, right? 1 by 2 will be your critical points. By likewise you need to break the intervals. Okay, so minus 1 by 2, minus 1 to minus 1 by 2. Okay, then minus 1 by 2 to 0, then 0 to 1 by 2, then 1 by 2 to 1. ओके, ऐसे ही हमें क्या करना पड़ेगा, फंक्शन को ब्रेक करना पड़ेगा. ओके, सो लेट्स सी. सो व्हेन x is in between minus 1 to minus 1 by 2, you can take any point in between minus 1 to minus 1 by 2. so ये mod कैसे ओपन होगा बेटा? टेल मी how this mod will be, or how this function will be open. It will be opening with negative sign. So this will be minus of 2x minus 1 minus of 2x plus 1. So basically it is giving you minus of 2x minus of 2x, that is minus of 4x. Okay, and when x is lying between minus 1/2 to 0, ये कैसे ओपन होगा? minus 1/2 to 0. अच्छा, सो ये तो नेगेटिव के साथ ओपन हो जाएगा, माइनस ऑफ 2x minus 1, and this will be opening with plus positive sign. So this will be giving you 2, right? 2x will be cancelled out. Here 1 cancel हो गया, है ना? This will be giving you 2. Okay, now we'll be considering when x lying between 0 to half. So both will be opening with positive sign. Yes or no? Both will be opening with positive sign. Oh, we can take 0 is not our 0 is not our critical points, na? So we can take this way. Intervals are like this, minus half to 1/2, and the third interval we can take half to 1/1, right? So when 1/2 to 1, so both the functions, so f of x will be opening with positive sign, na? That is 2x minus 1 plus 2x plus 1. So it is giving you 4x. अगर हम उसको थोड़ा अच्छे से लिख देंगे, so f of x is equal to, we are getting minus 4x when x is lying between minus 1 to minus 1/2, and it is giving you 2 when minus 1/2 to 1/2, and it is giving you 4x when 1/2 to 1, right? Acha, if we'll take equality sign, if we'll take equality sign in the given function, acha, agar hum equal to is equal to 1/2, minus 1/2 and 1/2 ले लेंगे तो, अच्छा, minus 1/2, if we'll take minus 1/2, it will be opening with a negative sign, the minus 1/2, 2x minus 1, and this will be also opening with 2x, or minus 1/2, check at minus 1/2 and at 1/2. This will be 1 plus 1. So this is also 2. So we can use here when x is equal to minus 1/2 and 1/2 also we can take like this way. Okay. So this is my f of x. Guys, this is clear or not? This is my f of x, and also g of x is given as fractional part of x. Is that or not? Current chala gaya bhai. Okay. This is my g of x. Now finally you can take what is given in the question, this and this, f of g of x. Okay, now you have to find f of g of x, right? F of g of x you need to find. So how we can find f of g of x? F of g of x will be, there will be also 3 interval you will be getting, and when x is lying between minus 1 to minus 1/2, and also you will be getting x is lying between minus 1/2 to 1/2, and x is lying between 1/2 to 1. Okay, so this will be f of g of x. So now we'll be considering when here for f of g of x, my input becomes g of x, right? So instead of x, we have to take g of x, right? So for g, the domain is given as in the function. For g, the domain is given in the question minus 1 to 1. Okay, and all of you know this fractional part of function is also given at 0 to 1, right or no? Range of fractional part function is 0 to 1, yes or no? So, and my critical points is 1 by 2, right? So if we'll break this interval by using the critical points 1 by 2, so it will be giving you 1 by 2 to when g of x is lying between 1 by 2 to 1. And another thing is, if g of x is lying between 0 to 1 by 2, two intervals, you can check for these two intervals. F of g of x will be, see, when g of x is lying between 1 by 2 to, why we are not taking this? We have to just neglect this thing, because we are taking when g of x, the range of g of x is 0 in between 0 to 1. So we are not talking about the negative interval. So that's why I'm neglecting this negative interval and I'm taking from this, because I'm breaking this interval. Okay, so now tell me, when g of x is lying between 1 by 2 to 1, when the input is lying between 1 by 2 to 1, okay, then the function gives you 1 by 2 to 1, sorry, this. When the, what is the nature of f of x? When the input is lying between 1 by 2 to 1, function is giving you 4 times of x. That is, here you will be getting 4 times of g of x, because in place of x here you are having g of x, na? Okay, and when the function, when g of x is lying between 0 to 1 by 2, or we can check when the input is lying between 0 to 1 by 2, the function giving you 2. So this will be 2. Is it or not? Now if we'll अच्छे से उसको थोड़ा भी हम लिख सकते हैं, है ना? Okay, if we'll write this as also, थोड़ा अच्छे से और भी लिख सकते हैं, just leave this. This is my f of g of x. Okay, now we can easily draw the graph of this function. Try to draw the graph of this function. Okay, so total domain is given as -1 to 1, right? So I am taking, this is my -1, this point is 1, and this point is 0, this is 1 by 2, and this is -1 by 2. Now this is my function f of g of x, right? And try to find f of g of x in each of the intervals, okay? So let's see, if we'll check for in between, when g of x is lying between, or sorry, when x belongs to 1 by 2 to 1, right? 1 by 2 to 1, then g of x will be, g of x is actually fractional part of x, na? So if you are taking any point in between 1 by 2 to 1, so g of x will be giving you same fractional number, that is what it is, what it will be giving you, that is x minus greatest integer function. So greatest integer function, if you are taking any number in between half to 1, then this will be 0. So you are getting x only. And so g of x is x. If g of x is x, then g of x is belongs to 1 by 2 to 1. Right or wrong? G of x is also belongs to 1 by 2 to 1. Okay? If x belongs to 1 by 2 to 1 and you are getting g of x is equal to x, then g of x is also belongs to 1 by 2 to 1. Yes or no? अरे x की जो भी रेंज हुआ, फिर g of x की तो वही रेंज हो गया ना, ठीक है? Yes or no? So then f of g of x will be, क्या हो जाएगा? f of g of x, अच्छा, when g of x is lying between half to 1, so f of g of x is 4 into g of x, that is 4 into g of x. Okay, So 4 into g of x is x, that is x, 4x. So for this interval, when x belongs to 1/2 to 1, you are getting f of g of x is as 4x, right? Similarly, you need to find when x belongs to 0 to 1/2. Acha, when x belongs to 0 to 1/2, so g of x will be same, x हो जाएगा fractional part of x, that is also x minus greatest integer function of ये तो 0 हो जाएगा, फिर this will be giving you again x. So also, so g of x belongs to g of x also belongs to 0 to 1/2. Yes or no? If it is giving you when g of x belongs to 0 to 1/2, let's check the function. When 0 to 1/2, the function give you 2. So f of g of x will be 2. Yes or no? Let's check for the third interval, that is minus when x belongs to minus half to 0. Okay, so when x belongs to minus half to 0, so g of x will be x minus greatest integer function of x, that is x minus 1, x, you can check, you can choose any point in between minus 1/2 to 0, so it will be giving you minus 1. Greatest integer of that number will be giving you minus 1, so this will be x plus 1. Okay, so x plus 1, so when x belongs to minus 1/2 to 0, then g of x will be belongs to 0 to 1. Yes or no? 0 to 1 or not? Are minus 1/2 plus 1, so this will be 1/2 na. Are when x belongs to minus 1/2 to 0, so g of x belongs to क्या हो जाएगा, that is x plus 1 belongs to, so x add हो जाएगा 1 minus 1/2 plus 1, that is 1/2 to 1. Okay, so when x belongs to g of x belongs to minus 1/2 to 1, then f of g of x will be equal to 4 into g of x, and g of x here we are getting 4 into x plus 1, that is 4x plus 4. 4x plus 4. And in the fourth interval, when, बहुत lengthy question है actually, when x belongs to minus 1 to minus 1/2. Okay, minus 1 to minus 1/2, in this case also g of x will be x plus 1, and g of x, if g of x is x plus 1, so g of x belongs to minus 1/2 to g of x कहाँ रहेगा बेटा, ये हो जाएगा minus 1 plus 1, 0 to 1/2. Okay, when this is g of x belongs to 0 to 1/2, so f of g of x will be belonging to, this will be 2 or not? 2. Yes, so this is 2. Okay, so now you have defined the function f of g of x for all the interval, for all the domain. Now you can write the function again. Okay, so f of g of x we are getting, that is sometimes it is giving you when g of x belongs to 1/2 to 1, it is 4x. It is 4x when g of x belongs to 1/2 to 1, and it is giving you 0, sorry, it is giving you 2 when g of x belongs to 0 to 1/2. 0 to 1/2, and again it is giving you 4 into x plus 1 when g of x belongs to minus half to 0, minus half to 0, likewise. And again you are getting another interval, that is when g of x in between, sorry, अरे g of x नहीं, x के बात कर रहे हैं ना हम, -1 to -1/2, -1 to -1/2, right? So this will be like this, and this is giving you in the last, what it is giving you, beta? 2. This is also giving you 2, and these are not g of x, we are talking about x. Okay, so this is my x, 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 x. Okay, now you have to draw the graph first, right beta? Oof, there is no current actually, huh? Now you need to use this information to draw the graph. Okay, if you use to draw the graph, suppose this is my graph, this is my origin, this is my 1, this is my -1, and this is my -1/2, this is 1/2. Okay, you can check here now. Okay, and suppose this is my 2, this is 4. Okay, so when x belongs to 0 to half, 0 to half, okay, it is giving you 2. That means the graph will be like this, y is equal to 2. Okay, y is equal to 2. And when x belongs to -1/2 to 1, sorry, 1/2 to 1, it is giving you y is equal to 4x. Likewise, the graph will be like this. This is y is equal to 4x. This is y is equal to 2. Guys, I'm switching off my video. Okay, चलो ठीक है, ये अगर हो गया, okay, now -1/2 to 0, -1/2 to 0, 4 into x plus 1, the graph will be like this. 4 into x plus 1, the graph will be like this. Y is equal to 4 into x plus 1. And x plus 1 means 1 unit will be shifting backward. है ना? ठीक है? So this, and then for minus x, when x belongs to -1 to -1/2, y is equal to, or from f of g of x is equal to 2. Right? So f of x is equal to 2. Right? So this is equal to y is equal to 2. So C is the number of discontinuity. C is the number of points of discontinuity. So C is equal to how many number of point of discontinuity you are getting? Only 1. At x is equal to 0, f of g of x has a jump discontinuity. Okay, it's not continuous. Okay, so this is why the number of point of discontinuity is 1. That is C is equal to 1, and number of point of not differentiability or non-differentiability is, there is a sharp point. Of course, at x is equal to 0, it is not differentiable, and also at this is a sharp point also. So 3 points, we are getting 3 points at x is equal to -1/2, 0, 1/2. These are the point of non-differentiability, or we are getting D as 3. So C plus D will be 3, 1 plus 3, that is 4. Is it clear, guys? So answer is 4. Clear? Very lengthy question. आया समझ में? So कोई डाउट है इसमें? डाउट है तो फिर से ट्राई कर लेना. फंक्शन को तो अच्छे से पूरा डिफाइन करना है तुम्हें. फंक्शन को ही समझना तुम्हें जरूरी है. ठीक है? एनी डाउट? यू कैन आस्क जल्दी से. टाइम हो गया. बोलो. Any doubt you are having? Any doubt you can ask. बड़ा. सोम, तरुण, अमृता. ठीक है, कोई नहीं. In this way, you have to find the function, then you need to draw the graph. After drawing the graph, you can find the answer. ठीक है? चलो. चलो bye bye, take care everyone, thank you all for your time, bye bye. Okay, I'll upload the PDF, don't worry.